Question 4, part B. There are two parts to this. Let's have a look at the first one. Find the probability that a box of cereal chosen at random is sold. Now, we are told in the sentence above that all boxes of cereal with a weight between 497.5 grams and 505 grams are sold, and that the income for each box sale is $2. But we'll get to the monetary part in the second sub-question of B. Let's just firstly have a look at this range of weights, and we'll show it on the normal distribution diagram here. So 497.5, well, this is 498 here, so 497.5 will be approximately about here, let's say. And I'll just illustrate that now. So 497.5 is there. And then 505 grams is right in between 504 and 506. So that'll be 505. So we are interested in this range here that I'm shading. Now, for a normal distribution curve, we're talking about probability here. So the total area under the curve will add up to be 1, because the totals for probability is 1. And then we want to find out the shaded region area. And looking at this shaded region, it's quite a lot out of the total amount. I'd probably say maybe 90% of the total area under the curve is shaded. So the probability is going to be roughly around 0.9, I would think. But we need to find out exactly what that is. And the way to do that is to use our graphics calculator. So let's bring the calculator up. We open up a scratch pad, go to menu, number 5, probability, and then number 5 again, distributions. And then for these normal distribution curve questions, we always use either normal CDF or inverse normal. These are the two ones that we need to get familiar with and that we always use. Now, the difference between the two is normal CDF is when you have the values on the horizontal axis, in this case weights, and you're looking for the probability. Inverse normal, on the other hand, is when you have the probability and you are looking for the values on the horizontal axis. So for this question, we have the horizontal axis values, 497.5 and 505, and we're looking for the probability, so we're going to choose number 2, normal CDF. Lower bound will be the left lower number, so 497.5. The upper bound will be 505. This line here is the mean, and that is 502. We were told that earlier in question 4. And this bottom line here is the standard deviation, which we were also told to be 2. So, okay, I was pretty close with my prediction, but it's 0.921. So we're going to round to 3 significant figures here. Actually, before I round, I'm going to write the exact answer, and you'll understand why I do that in a second. So 0.920968, 0.920968, and to 3 significant figures, that will be 0.921. Okay, so that is the answer to subpart 1 of the probability that a randomly chosen box is between these two weights. And for the expected daily income, we need to trace right back to the start of the question where we were told that the manufacturer manufactures 1,500 cereal boxes. So each day, 1,500 boxes are produced, or made, sorry. Now, 92.1%, or as a decimal, 0.921 of them fit between the range. So to find out how many of these 1,500 boxes fit between the range, we're going to multiply the total amount by the probability that they are within this range. And I'm actually going to multiply it by the exact number, not the rounded number, so that our final answer is more exact. So that will be, I already have the decimal probability there, so I can just multiply that by 1,500. So 1,381.45. 1381.45. So this is how many boxes out of the 1500 are expected to be between the weight range. Now we were also told that for each box sold, the manufacturer receives $2. So therefore, expected income will equal the number of boxes between the weight range multiplied by how much the manufacturer will get, and that equals, so multiply that by 2, so 2,762.91, 2762.91, and to 3 significant figures, because the question doesn't ask whether to give it to the nearest dollar, so we give our answer to 3 significant figures. That will be 2760. And they are the two answers to part B, question 4.